Alright, in this video we are going to learn whether inverses exist based strictly on the graph of what the original is. And it's referred to as the horizontal line test. First thing I want to remind you of is that when we were studying functions, there was a rule that in order for something to be a function, it had to pass the vertical line test. A vertical line could not intersect the graph in more than one spot to be a function. Okay, what that meant was an operation that looked like that passed. Because if we took a vertical line anywhere, it would only pass through once. However, if we had a function that looked like this, okay, that one doesn't pass because a vertical line could pass through as many as 4 spots on there. So that is not a function. All right, so keep that in mind as we go through the horizontal line test, because the inverse, as you've already gotten used to hearing, is kind of the opposite. So in order for a function to have an inverse, it's a horizontal line that cannot pass through the graph of the original function more than once. Yeah, all right, there we go. So what the horizontal test is specifically, it says if a function f has an inverse, if and only if no horizontal line intersects the graph at more than one point. So the first thing I'm going to do is show you an example of this that might actually kind of surprise you. And that is this simple example. Of course, you recognize that. We just talked about that. That's the x squared graph. If I place a horizontal line through it, it goes through in more than one spot. It goes through right there and right there. For that reason, x squared has no inverse. My guess is that you're probably surprised to see that something as simple as y equals x squared does not have an inverse. But let's take a closer look. If we were to flip this graph across the line y equals x, and remember that's what it means to be an inverse. The graph is flipped across the line y equals x. Actually, I'm not sure we even talked about that yet. We will in a minute. Here's the graph of the air quotes inverse. Okay, so the inverse, if you look at it, would not pass the vertical line test. Okay? A vertical line goes through this in 2 different spots, meaning that this right here isn't a function. So although x squared is a function, the inverse would not be. That's why it has no inverse. And if you think about what the inverse of x squared is, you would probably be thinking that it's y equals the square root of x, which is true. But when you take y equals the square root of x, actually the only thing that gives you is the top half of the graph. You would have to graph negative square root of x to get the bottom part of the graph. Okay, so you'd need a second function to get that bottom half of the graph. So again, the whole horizontal line test is merely a simple way of showing that if it doesn't pass the horizontal line test on the original, then it's not going to pass the vertical line test on the inverse. And one last thing about the horizontal line test. A function f is one-to-one if each value of the dependent variable corresponds to exactly one variable or one value of the independent value. Function f has an inverse if and only if it is one-to-one. Okay, so that's saying, remember, if an x got mapped to two different y's, it's not a function. Okay? X had to be matched to only one y. All right? Now, the converse of that is, remember the domain of the original is the same as the range of the inverse. So, and the same with the range in the domain of... Ay caramba, this isn't the easiest thing to say. You remember that diagram that we did? Here's all the x's, gets mapped over there, these are all the y's, and then you go back. This is f inverse, and this is f. Okay, so anyways, the y values that you got out of f are what you use to plug into f inverse. All right? So if you know that it's one-to-one, so x goes to a specific y, and you only have one y there, and it goes back to a specific x in the inverse, then it's one-to-one. All right, so an example of a one-to-one. Well, let's see. This is an example of a one-to-one because for that x right there, it's only plugged into one y over there. And this y has only one x. That's a one-to-one function. Okay. This is not one-to-one because although this x gives me only one y, this y gives me in fact two x's. Therefore, not one-to-one. Okay, and there are a bunch of one-to-ones, but more than it's more typical that a function is not one-to-one than it is one-to-one. Anytime you have any curving like this, you're going to have something that's not one-to-one. Not to say that all curves are like that, because I could give you this graph. That graph is one-to-one. Okay, so just keep that in mind. One x mapped up to one y and one y mapped to one x. That's it. That's what it means to be one-to-one. And that is going to be the end of this video.